You're plummeting from the sky at breakneck speed, wind roaring in your ears like a personal hurricane, the ground rushing up like an unforgiving executioner. But here's the heart-stopping question. How high can you fall and still survive? According to science, the answer isn't a fixed number. It's a deadly dance of physics, luck, and human biology that's led to real-life miracles. Stick with us, because we're re-unraveling this enigma that could save lives or ignite the next era of human exploration, from skyscrapers to the stars. Welcome to our deep dive into how high can you fall without dying. According to science, if you're new here, smash that subscribe button now. We experts at cracking open scientific mysteries with stories that keep you glued to the screen. Let's dive in. Falling from extreme heights isn't just action movie stuff. It's a phenomenon that's fascinated scientists for centuries, from Galileo's gravity experiments to modern simulators predicting impacts with surgical precision. But understanding it means looking past the initial terror. It's a lesson in the limits of the human body and how technology might push them further. Let's break it down into 4 key parts. The physical problem of lethal falls, the current state of survival based on real data, future implications for human progress, and a speculative scenario that'll make you dream of a world where heights don't scare us. Let's start with the core issue. Why is falling from great heights usually fatal, and what's physics got to do with it? Picture your body as a projectile launched into the void. Gravity pulls you down at 9.81 meters per second squared. No mercy. In the first few seconds, you gain speed fast. From 10 meters about a 3-story building you hit at roughly 50 kilometers per hour, enough to break bones if you land wrong. But as you fall higher, air resistance kicks in, that invisible force slowing your descent. Around 450 meters, you hit terminal velocity, where gravity and drag balance out, and you stop accelerating. For an average 70-kilo human in a spread-eagle position, that's about 200 kilometers per hour, or 55 meters per second. Sounds brutal, right? It's like slamming into a wall at highway speed. The impact causes massive deceleration. Your body goes from 200 kilometers per hour to zero in fractions of a second, releasing energy that shatters tissues, organs, and bones. Biomechanical models show the skull can withstand up to 5,000 newtons before fracturing, but a terminal velocity impact can exceed 100,000 newtons. How you land matters. Feet first reduces damage by spreading force through the legs, but risks of internal bleeding or spinal injuries remain high, and the surface concrete is deadly, but water or snow can cushion, though water at high speed acts like cement. Global medical reports show falls above 18 meters are fatal in 50% of cases, rising to 90% above 30 meters. It's a matter of kinetic energy, half mass times velocity squared. Higher fall, faster speed, more destruction, but it's not absolute. Variables like age, weight, and luck play huge roles, making every fall a physical roulette. Now, let's look at the current state. What are the real heights humans have survived, and what does science say? History is packed with miracles that defy logic. Take Vesna Voloviyo, a Serbian flight attendant who in 1972 fell 10,160 meters after a plane explosion, landing on snow that cushioned her impact. She suffered multiple fractures and a temporary coma, but lived to tell the tale, earning a Guinness record. Another case, Alan McGee, a World War II bomber crewman, fell 6,700 meters without a parachute in 1943, crashing through a glass station roof that broke his fall. He walked away with serious injuries. More recently, in 2024, a Chinese climber named Yang Meng slid down a mountain, effectively falling hundreds of meters into a ravine, escaping with scratches thanks to bushes and rocks, slowing his descent. Posts on X from neuroscientists in 2025 discuss how the body shifts into survival mode. Adrenaline constricts blood vessels to minimize bleeding, and instinct positions the body to reduce damage. Vast data analysis, using AI to simulate thousands of scenarios, shows survival hinges on gradual deceleration. A 2023 biomechanics study reveals landing on deformable surfaces like hay or deep water boosts survival odds by 40%. In urban falls, from buildings, 50% survive up to 4 stories, 12 meters, dropping sharply after, but exceptions abound. A kid in 2024 fell 15 stories from a New York building, saved by an awning. Emergency data shows kids fare better due to flexible bones and lower mass. Terminal velocity is key. At 200 kilometers per hour, impact equals 50 times Earth's gravity. But slowing down via branches or wind boosts survival. Counter-arguments exist. Some experts question records like Valovier's due to altitude discrepancies, but forensic evidence backs most cases. Today, with massive accident datasets, science predicts survival with 85% accuracy, showcasing our edge by analyzing complex variables others overlook. So, what are the future implications? Understanding fall limits doesn't just save lives on Earth, it drives progress in universal themes like technology and space exploration. Imagine engineers using this science to design buildings with smart safety nets that detect falls and deploy shock absorbers. In aviation, automatic parachutes on planes could prevent tragedies based on simulations of terminal velocities. But it goes further. In space exploration, where low gravity on moons or asteroids means slow but potentially deadly falls due to heavy suits, this knowledge is critical. NASA reports in 2025 use AI to model impacts on Mars, where gravity is a third of Earth's, allowing safe falls up to 50 meters. This accelerates colonization. Astronauts could drop from Martian cliffs without fear, using exoskeletons that absorb shocks. In medicine, regenerative therapies inspired by survivors could strengthen bones with nanomaterials, cutting fall-related deaths, which cause millions of injuries yearly. A 2024 World Health Organization report notes that better understanding of deceleration could slash fall fatalities by 30%, while skeptics argue terminal velocity is unbeatable without gear. Breakthroughs in materials like aerogels suggest protections that turn lethal impacts into bruises. This sets our approach apart. By simulating complex outcomes with vast data, we predict and prevent, paving the way for a humanity that conquers heights and stars without fear. Now, let's speculate. It's 2040, and science has shattered barriers, using bio-integrated suits with AI, inspired by current research like DARPA's exoskeletons. You fall from low orbit, say 100 kilometers, and survive. The suit detects the fall, deploys microparachutes to cut terminal velocity to 50 kilometers per hour, then inflates gel cushions that distribute impact like a giant airbag. This isn't fantasy. It's rooted in 2025 studies using neural networks to simulate orbital descents with 95% accuracy. In this world, space explorers jump from orbital stations to planets, using gravity for efficient travel, hibernating in controlled falls. Extreme athletes drop from the stratosphere without parachutes, guiding position with built-in jets. But there's a dark side. Corporations could exploit it, creating aerial workers in megastructures without safety nets, or militaries using it for covert drops. What if the suit's hacked? You're in fatal freefall. Though some doubt the timeline due to energy challenges, advances in quantum batteries make it plausible. What's your take? Would you dare an orbital drop? Drop it in the comments. Stepping back, surviving falls isn't just physics. It's a testament to human resilience and how science stretches limits. With tools simulating impossible scenarios, we're close to a future where heights inspire, or not terror, redefining progress in technology and space. One common concern: can we predict survival? Data shows variability, with less than 1% surviving extreme falls, but AI models minimize risks. So, if you face heights, remember, position and surface save lives. We've only hit the ground on this dizzying topic. If it rocked you, smash like and share with thrill seekers. Subscribe and hit the bell for more science that defies the impossible. Tell us in the comments, what's your wildest fall story, or what height scares you? Keep the conversation going. Until next time, stay grounded and conquer the heights.